1.7 works with solving inequalities. Today we're going to be just working with linear inequalities, so anything that's got an x, not an x squared, x cubed, any of that. So with these inequalities, what your whole idea is, you're going to treat them just like they are equations. You're going to get your x or your variable by itself. With this, whenever you have a negative that you are multiplying or dividing on each side, you want to make sure that you flip that inequality sign. So you got to keep in mind your rules when you're doing these and when you're solving these inequalities. So if we look at our first set of examples, the first inequality that we're solving is 3x is less than 9x plus 4, and we're sketching the solution set. So with this, we have the first get our x's to be on the same side. To do this, we are just going to move the 9x over by by subtracting it to each side of your inequality. So these are going to cancel out. That 4 is going to be dropped down, so we're going to have negative 6x is less than 4. From here, we just divide each side by that negative 6. Remember, you're dividing each side by a negative, so that inequality sign flips. So we have x is greater than negative 2/3. So this is our solution. To graph it on that number line, we're going to find that negative 2/3, which is about here. We're going to have an open circle on that negative 2/3. Our sign points to the right when our variable comes first. So our line's going to also run to the right. For example 2, we have 4 is less than or equal to 3x minus 2, which is less than 13. So with this one, we have a compound and inequality. For these, we want to get the variable alone in the middle. So by doing this, you could do it one of two ways. You could separate this into two inequalities and bring it back into one compound inequality, or you can just work with the compound inequality. I prefer to just work with the one compound inequality. So what I'm going to do is undo any addition or subtraction first that happens in the middle of that inequality. So that minus 2 is going to be undone by adding the 2, and we would do that to every part of this inequality. So the 2's in the middle cancel. The 4 plus 2 gives us 6 is less than or equal to 3x, which is less than the 13 plus 2 is 15. From here, again, we want x by itself. It's being multiplied by that 3 right now, so we're going to divide each part by that 3. Those cancel, so we just have 2 is less than or equal to x, which is less than 5. When we have our final answer here with these compound inequalities, especially with an and statement, you want the number that is the smallest out of the 2 on the far left side. So we look at these two numbers. We have a 2, we have a 5. The smaller number is the 2. It's on the left, so we do not have to change anything or rearrange anything. So we just have the 2 is less than or equal to x, which is less than 5. On your number line, you find the 2, you find the 5. You're going to have a closed circle on that 2. You're going to have an open circle on that 5. And then your line's going to run in the middle to connect those two circles. So our next example, yours in your notes says 2 is greater than or equal to 8. Plug in that x next to 2x is greater than or equal to 8. And we're just getting the x by itself. We're solving each of these. Your directions for these is tell you to express each answer in interval notation. I'm going to go over that briefly with you. However, I don't think we're going to test you or quiz you on interval notation since we haven't gone over that, but at least you'll know what it looks like. So with this, the way that we would work this out is we would just divide each side by that 2 to get x by itself. We have x is greater than or equal to 4. Now, thinking about this, x is greater than or equal to 4. If it's greater than that 4, it's going to go, like, you got to think of your number line and when you graph this. It's a lot easier to graph it first. Call it the 4. You'd have a closed circle in that 4. That line runs to the right. Your variable comes first, sign points to the right, line runs to the right. Again, once we do this, it's a lot easier to take your interval notation from it. What interval notation is parentheses or brackets that have the number that's included within the inequality, and it goes to either infinity or negative infinity. So with this one, since it's greater than, look at that line. That line that you drew on the number line is going to positive infinity. So the two numbers that you're going to have within this interval notation is the number that the circle is on, which is 4, as well as the number that the line goes to. In this case, is positive infinity. You separate these two with a comma. Now you want to look at your circle. If you have a closed circle on the number 4, we put a bracket on that number. The infinity or the negative infinity always get parentheses on it because we don't exactly know where that infinity stops. It goes on for forever. So what these parentheses and brackets represent, a bracket means that it includes that number. The parentheses means that it's not including that number. So anytime you have a greater than or less than symbol, it would just get a parentheses on that number. If it's equal to, that's when it gets the bracket, just like when a closed circle or an open circle. If we look at number 2, we're given 3x plus 11 is less than 5. So with this one, I just start by moving moving the 11 by subtracting it from both sides. I'm going to be left with 3x is less than negative 6. I then just divide each side by that 3 to get x is less than negative 2. So again, I'm going to graph this first before I give my interval notation, just so that way it's easier for me to see. So I would find that negative 2. My sign is just less than, so it doesn't include the negative 2, so it's going to be an open circle on the negative 2, and then it's going to negative infinity, so it points to the left, the line runs to the left. So with this, my inequality, or my interval notation, I want my two numbers that are included from this graph. I have a negative 2, and I have a negative infinity because that line goes to the left, so it goes to negative infinity. Now, with the way that you write these, your smaller number will always go on the left, bigger number will always go on the right. Because this is going to negative infinity, that negative infinity is going to have parentheses on it. Because we have an open circle, that negative 2 also has a parentheses on it. So this interval notation of this parentheses, negative infinity, comma, negative 2, close parentheses, just represents that our variable is less than negative 2. For example 3, we have 1 is less than 5 minus 2x. For this one, I'm going to move that 5 over first by subtracting it from each side. I get negative 4 is less than negative 2x. And then I just divide each side by that negative 2. Remember, when you're dividing by a negative, that inequality sign flips. So that negative 4 divided by negative 2 gives us a positive 2. We flip the sign, is greater than, we have x left over. Now, this inequality does not have my variable first, so I'm just going to rewrite it to where my variable comes first, so it's a lot easier for me to see which way my line is running. If my variable comes first, I'm going to have x. My sign is open to the 2. It's going to stay open to 2, so x is less than 2. On our number line, we find that 2. It's not equal to that 2, so we're going to have an open circle on the 2. When our variable comes first in our inequality, my sign points to the left, so my line is going to run to the left. If my line runs to the left, that means I'm going to negative infinity. And I also have that 2 where that circle's at, so my negative infinity and my 2 are going to be in my interval notation. Infinity and negative infinity always get the parentheses on it. This 2 has an open circle, so that also gets the parentheses. For example 4, we have 2 times 7x minus 13 is less than or equal to 12x plus 16. Now you could do this one of two ways. You could, since the number that you're distributing in is divisible, is a number that goes into both terms on the right-hand side of this, you could start by dividing each side by the 2. You don't have to. You could distribute the 2 in first, which is what we're going to do. So that way you get 14x minus 6 is less than or equal to 12x plus 16. From here, I would move my 12x to the other side by subtracting it from each side. I'm left with 2x minus 6 is less than or equal to 16. And then I just add the 6 to both sides to get 2x is less than or equal to 22. And finally, I divide by 2 to get x is less than or equal to 11. On my number line, I'm going to find that 11. Because it is equal to 11 as well, I'm going to put a closed circle on that 11. When my variable comes first in my inequality sign points to the left, so my line runs to the left. To write this in interval notation, my line's running to the left, so I have negative infinity, and then the number that my circle is on is 11. That infinity and negative infinity always get a parentheses. And that 11, since it has a closed circle, it includes that 11, so I'm going to put a bracket on the 11. For number 4, we have 5 is less than or equal to 3x minus 4, which is less than or equal to 14. So with this, I'm going to add the 4 to every part to start. This is leaving me with 9 is less than or equal to 3x, which is less than or equal to 18. From here, I just divide each part by 3, and I'm left with 3 is less than or equal to x, which is less than or equal to 6. Now, you can think about this as x is greater than or equal to 3, and x is less than or equal to 6. This might help you when you're graphing it. To graph this, you have that 3, you have that 6. We're going to have a closed circle on that 3. We have a closed circle on that 6. Those two inequality signs point into each other, so our line connects the two circles. From here, your compound inequality is represented a little differently with your interval notation. Your interval notation for both of these inequalities is going to be that x is greater than or equal to 3, which means you have 3 to positive infinity, including that 3, and x is less than or equal to 6, so you have a negative infinity to 6, including the 6. This has an and statement, so what that means is what are the numbers that make both sets true? So what are the numbers that are the same from each inequality? If x is less than or equal to 3, then we have 3, we have 2, we have 1, 0, greater than 3 is x is greater than or equal to 3. That means that we have 3, 4, 5, 6, 7, so on. For the x is less than or equal to 6, that means we have 6, 4, 5, 4, 3, 2, so on. So because we have an and statement here, what are the numbers that are the same for both of these? The 6, the 5, the 4, the 3. So this is only including 3, 4, 5, and 6, which means in our interval notation, It includes the 3, so the 3 would have a bracket, all the way to the 6, which it includes the 6 as well. So your correct form of your interval notation would be this bracket 3 comma 6 close bracket. Alright, so for this example we have -8 is less than or equal to 5x minus 4, which is less than or equal to 5. So we're going to do the same thing. Undo the subtraction or addition in the middle first. So we're going to add the 4 to every part. We have -4 is less than or equal to 5x, which is less than or equal to 9. From here, we divide each part by 5 to get x by itself. So -4/5 is less than or equal to x, which is less than or equal to 9/5. Now again, if you want to make things easier for yourself to graph this, we can rewrite it as 2 inequalities. It would just be x is greater than or equal to -4/5, and x is less than or equal to 9/5, which is 1 4/5. So on our number line, we're going to have a closed circle on -4/5, which is going to be about here. We also have a closed circle on 1 4/5, which is about here. Our line goes in towards each other, and then your cheat pretty much with your compound and inequalities. Just include the two numbers with brackets on them if it's equal to -4/5, 9/5, and separate them with a comma. For our last example, we have -3 is less than or equal to 3x plus 7, which is less than or equal to 1/2. So with this one, I'm going to subtract 7 from every part. Now, when I subtract 7 from that right side, I'm going to turn it into something over 2. So that way I can subtract those two fractions, and it makes my life a little easier. So those 7's cancel out. -3 minus 7 is -10, is less than or equal to 3x, which is less than or equal to 1/2 minus 14/2 is -13/2. We then divide each side by the 3. Now when I write this, I'm going to write it as a fraction divided by 3/1 on that right side, so that way I remind myself, keep, change, flip. Those 3's cancel. We're going to have -10/3 is less than or equal to x, which is less than or equal to. That -13/2 stays, times 1/3 becomes -13/6. Now, I'm going to rewrite this so that way I have like denominators, just so that way it gives myself a little bit of an easier way of looking at this. So this is going to give me -20/6, which is less than or equal to x, which is less than or equal to -13/6. I compare my numerators now. The one on the left is in fact giving me the smaller number, so I'm okay. I do not need to rearrange anything. If my inequality doesn't have the smaller number on the left, I need to write it to where that smaller number goes on the left. Okay, so from here, I'm just going to graph this. If I wanted to, I could have changed that -10/3 into -3 1/3, and then that -13/6 is -2 1/6. This might give myself a little bit easier way of graphing this, just so that way I can represent this a little bit better. So on my number line, that -3 1/3 is going to get a closed circle. It's going to be about here. And then that -2 1/6 is going to get a closed circle, and it's going to be about here. It's an and statement, so those two go in towards each other. And when I go to write my interval notation, they the signs include both of the numbers, so I'm going to have brackets, and then negative 10 over 3, comma, negative 13 over 6 with a closed bracket.